everyone, I'm Zhuo Chen, a PhD candidate at Zhejiang University, advised by Professor Yajun Zhou. Today, I will present our research, Dissecting Payload-based transaction phishing on Ethereum. Payload-based phishing has evolved into a sophisticated attack vector, with over $3 billion lost to crypto scams in 2023. So what makes these attacks uniquely dangerous is their technical sophistication. They utilize Ethereum's transaction mechanism against users. Let's break down a typical transaction flow from blockchain perspective. First, user use the app to sign a transaction. Second, Ethereum receive a signed transaction from user. Third, EVM invokes the relevant smart contracts according to the transaction payload. Finally, the state of blockchain is modified and the app notifies the user. The critical vulnerabilities lies in step 3. The payload determines contract interactions, but most users never inspect this data. From the user perspective, it's deceptively simple. First, they will visit the app website. Second, they click Connect Wallet. And finally, click the button to sign the transaction. This simple UX creates dangerous blind spots. There is a huge gap between the user and the contract. In our research, we define payload-based phishing as transactions that manipulate smart contracts interactions through the execution of malicious payloads to deceive users. Here is an example. On the left is a legitimate NFT purchase order. On the right is a phishing NFT purchase order. They have the identical interface execute, but with different parameters. 100% fees on the right. Let's see what will happen. So first, the benign transactions completes a standard NFT trade. The seller loads NFT and gets Ethereum. The phishing transactions use a malicious payload to get NFT ownership from the seller, transfer funds to NFT market. However, due to the 100% fees, the NFT market will return all funds back to the scammers, and it results that the sellers lost NFT but get nothing back. While existing studies focuses on Web3 scam on the app, tokens, NFTs, our study reveals a critical blind spot. Systematic analysis of payload-based transaction phishing is needed. In our study, we take 3 steps. First, we're dissecting payload-based phishing categories, and based on these categories, we design a detection system. Using this detection system, we then finally perform a large-scale phishing measurement. First of all, we need to set up a ground truth dataset. First, we collect public reports from security companies such as FOTA, BlockSec, PackShield, and Scam Sniffer. Second, after the manual check, and we then expanding from the historical Ethereum transactions. And to compare with the phishing transactions, we also collected top 5 QL and DeFi developer transactions as benign transactions. The time duration of our dataset collection is January 1st to July 30 in 2023. Finally, we get 5,000 payload-based phishing and over 13,000 benign transactions. Based on the dataset, we identify 2 main phishing categories. First one is abusing legitimate contracts, and second one is exploiting phishing contracts. They have truly different threat model. Look at the right picture. In abusing legitimate contracts, we find two typical subcategories. First is the ice phishing scam, where scammers utilize token approval mechanism to cheat users' token allowance and drain all users' assets by the transfer from function. According to different scam tricks, the ice phishing can be further divided into approval permit and set approval for all. Here is an example on Ethereum. So another subcategory is the NFT order scam, which we show an example above. First, scammers analyze the NFT market contracts. Then scammers analyze the contract and generate the scam NFT order. So after users sign this scam order, they will lose their assets. So according to the different tricks, it can be also divided into bank transfer, proxy upgrade, and free by order. So here is an example of proxy upgrade on Ethereum. Turn to exploiting the phishing contracts. We also find two typically scam subcategories. The first is the address poison scam, an interesting and well-famous type. So first, when users initiate a transfer, attackers will monitor this transfer and quickly generate a lookalike address. Then the attackers invoke the phishing contract to poison the user's address. According to different tricks, it can be divided into zero value transfer poison, dust value transfer poison, and fake token transfer poison. So since the fake address is so similar to the normal ones, the users may transfer their fund to the fake address. So due to this abnormal zero value transfer behavior, the users can even flag this type of transfer. So finally, the payable function scam is not another is the other subcategories of the exploiting phishing contracts. The scammers utilize a fake interface and airdrops the rubbish token to the users. And if the users believe this airdrop and invoke the phishing smart contracts, they will lose their assets. Okay, according to different function names, it can be divided into airdrop function, wallet function, such as the claim airdrop, claim reward, and security update. So from our categorization, we have an insight. Phishing transactions are different from normal ones. So in four perspectives. First is the contract bytecode patterns, and second is the input data signatures, and third is the transaction related addresses, and the final one is the transaction history. So we designed and implemented a rule-based detection system. So here is the detailed detection rules of our system. So, however, due to the time limit, I cannot describe all the details in this present. So, if you are interested in this, you can get all the details from my paper. Okay, turn to the evaluation. So in our ground truth dataset and the additionally large-scale reality Ethereum dataset, our detection system achieves both high accuracy over 99% and the time consumption is very light compared to the time generated by the Ether scan. So with only 390 milliseconds per block on average. So based on our detection system, we perform a large-scale measurement from December 31 to October 27, 2023. We find over 130,000 phishing transactions and this causing 341 million losses. So here is the time loss graph and here is the detailed loss tables. Okay, during our measurement, we find interesting behavior that we find the joiner family, or also called the joiner as service family, and find some famous family like Venom joiner, Inferno joiner, and Angel joiner. Okay, finally, we show our contribution to community. So we reported 1,726 phishing addresses, accounting 43% of all community reports. And in the meanwhile, we also send on-chain alerts over 2,500 messages to helping 1,908 victims. So this is our contribution. Payload phishing represents a fundamental challenge to Web3 security. So let's work together to build safer, decentralized system. Thank you.